let's start. So, hello everyone. This is ETCD robustness test meeting, and today we have this December 4th, and we are starting on a new time. We moved the meeting 3 hours later, and there was a lot of a lot of people moved time zones, and we have new people joining. And after a couple of meetings, we figured out that it will be very beneficial for us to move the meeting later, so more people can join. So thank you if you're attending. Hopefully this new time is working for you, and I think we can start. So just copying the normal agenda from the last meeting. So yeah, we usually start with questions. If there's any questions or from people new or wanting to work on robustness tests and they're not sure anything, if you have any question, please post them below so we can discuss them together, so the answer will be available for more people. If you're not shy, if everything is clear, I think we can, or if there are no other questions, we can move to the next topic, which is recent issues. So I already talked on previous meetings. We have still one pending correctness issue, and that would be good if. Oh yeah, this has been happening recently. Yeah, so, GitHub has some issues. Or at least I don't know. It doesn't work for me on some issues. Yeah. So okay, it works now. Yeah, we have one issue. It's very, let's say, obscure case of API usage that hopefully or was added long time ago, but apparently no one it was not tested or used broadly, so which ended up with us having a very clear issue during or one optimization allowed very easy and correctness issue or basically an inconsistency. Don't think fix is simple. So if anyone is interested from correctness perspective, it should not be too hard. But yeah, and as always, for every issue we post, we should have a matching robustness test to make sure we learn from our mistakes and we cover this API. So we should make sure that this API is also covered. So if anyone is interested in that, please take a look into the pinned issue. If someone is interested in writing, I don't think there is an robustness test, regression tests yet, but you can create one now. Like same like here, we have a regression test here. Let's just open one feature. Yeah, let's just use it as a template. Yeah. Any questions uh, for the regression? Okay. Yeah, and there's still a couple of there's still other issues open for the robustness testing. If there anyone is interested, please let me know. I don't think we had any new discoveries since KubeCon, but there's still a couple of regression tests that we should write to cover. Yeah, prevent any new cases. I think I should start pinging people because if there is a couple of issues that are assigned, but I haven't seen a progress on them for some time. Yeah. So let me maybe link the issue, and I didn't mark this as robustness test. Maybe not a feature. Yeah. Okay. If not, let's go just to the pro. Since last meeting, uh, so to looking at the, I don't think I fixed, but yeah, on the last meeting, we finally made a decision to cover to address those two issues, and I merged two fixes. So the common recurring issue was member replace, but as it turned out, and we started analyzing cases, all the cases with member replace happened on the 3.4, and that was because I think yes, we it turned out that member replace. Maybe I can close it. Doesn't it depends on linearizability of one of the methods that is not linearizable in 3.4. So hopefully we still haven't like this. Oh yeah, and so maybe let me add it to agenda since last meeting. And there is one improvement is the member replace is now fixed. So I think this merged. Yeah. This merged 2 days ago. We'll wait and see if the regressions, we stop seeing regressions. And the other was relating to the QPS. One so QPS has been like like long-standing issue for the robustness meeting. Main reason is it's not trivial to reproduce every race between controllers or not controllers between coroutines, especially if there is a race between two coroutines at the same time. And yeah, and historically I was standing for keeping the QPS requirement high, because at the beginning it was easy. um, Mm, uh, because it was easy and it allowed us to reproduce one of the old issues, one of the first issues that we had, um, which required coordination of two coroutines crashing and etcd crashing at the time, at the specific time in both two coroutines. There is a issue to maybe make it easier to reproduce such cases where you can coordinate multiple coroutines in etcd to reproduce it, but you still like to have this situation. You need a lot of QPS for those two coroutines to have higher probability to execute at the same time. Uh, so yeah, unfortunately, it's most of the meetings, or not lowering the QPS resulted in most of the meetings like having spending a lot of time on just looking through um, the dashboard, and I think at the end it's not productive. So I decided to lower the QPS. The important stuff for from the QPS. One thing that we should still consider is maintaining or keeping track of the QPS and maybe tuning it or accordingly to the problems or bottlenecks that we see and discovering those bottlenecks. So in the meantime, I created an issue to analyze the QPS, how what's the distribution of it, and I wrote a couple of scripts, and that resulted in this table. And this table is just like shows the different percentiles of QPS that we reach. So at the max, we reach one over 1,200, which I think that currently we set this is only limited by the rate limiter introduced into robustness test, just to not uh, not generate too much operations too quickly, because this increases the cost of linearization. So we have a limit. So this is, I think, the current limit is 1,200, and this is just a burst. So it's allowed to burst. So this is a result of burst. But on the lower end, we can see some cases that don't even hit 200 QPS. And this is like, of course, lazy FS, which we reduce the QPS requirements. So high level, we should I hope we would be able to use such data analysis to find where is the problem. Is this the problem of specific scenario, or is it a problem of find the bottleneck which is causing it. So for example, here we see that etcd with deletions and leases hits much lower QPS than one node cluster hits much lower QPS than 3-node cluster. So maybe we should look into that, so we can balance it or look at why there is a bottleneck here, and what operations exactly feed into that. If anyone would be interested into looking or into helping with that effort, I investigated two ways to do that. One is one of the features of TestGrid, which is the TestGrid has a support for graphs. So if you can track here, it's very useful to have a track of how much time is each test takes. So you can see how much time we spent using, like on this scenario, how much time we spent on this scenario. And you can get this is average time from like some number of runs, like 4 or 5. But you can see like most of the the robustness tests are executed very fast, which is good to see and confirm. Like there is nothing like it's dominating the time. But we have one, or no, this is aggregate. Yeah, so at least one proposed scenario takes this. So my hope you would be able to to have this graph and have a separate graph to see what is QPS per it's how much QPS we get per each scenario, which could give us more visibility and maybe give some leeway to some specific scenarios while increasing the lowering requirements for some scenario we know that are very heavy, but making the requirements for other cases higher. And this is one approach to do that. I mean, this is one integration that we could do. The other one is used by Kubernetes Perf Dash. If you've ever done any scalability testing in Kubernetes, this goes into high level, like how Kubernetes keeps tracks of long time, soft metrics, long-term soft metrics. How do you measure? How do you measure a parameter that you not necessarily want to fail on, but keep track of it over time? Oh, if sorry, I haven't.
I want to know, is it possible to get the website we use to run the test? Yeah, I think sometimes the QPS might impact by the VM. So
We've been looking into that historically, or we already did this analysis. I think if you're interested into overall performance of etcd tests and specific or pro tests and specifically etcd, there is already monitoring dashboard for any execution of tests. So you can go here, find Kubernetes, find any organization, and see it runs. And here we see the robustness tests. And we see that robustness tests use around 2 gigabytes of memory and like maybe 5 CPUs. And this is running on like much bigger machines. I don't remember how to even check. Oh, this is limits. Okay. So we are using like 2 gigabytes out of 14, and we request 7 CPUs and use only like 0.
Okay.
Maybe. Yeah. So we already look at that. My guess, and only like left from performance point of view, only thing left that to investigate. I mean, it's not an investigation; it's experimentation. It's that this is a disk bottleneck. I'm not even sure, like 100% sure, because we write the etcd data to TMP files, which should be a in-memory TMP file system. So in most cases, we should not be bottlenecked on disk at all. But I don't know the setup in Pro. I mean, it just runs in containers. So I know question where is the TMP directory mounted in the specific setup. I think there is. Yeah, I think it's just a normal directory. I don't even. I don't think there is any specific mount in the. Or I'm not fully like expert on container runtime mounting. If it does any specific mounting on containers, just get. I assume containers get a fuse FS, so you don't mount the host temp directory. So technically, that means that we are writing to a normal disk, and because it's a Kubernetes Pro runs on Kubernetes, it means this disk is a boot disk for the VM. And this I don't think this boot disk for the VM is very large, and also which means it doesn't have a lot of QPS. So that's my Strawman thing.
Okay.
I don't know how much we can, or the only thing I think we could do is there is a setup used by Signal to run to run tests not on containers but run them on VMs. But I haven't didn't have time to follow up. It would be good to talk with SIG testing or test infra how to set it up and look at manifest or look at also pro configuration. That would be the easiest. I mean, that would possibly slow improve the situation, which and solve one of the problems. The second or the first problem is still we don't have enough visibility. So I think it's still worth to maybe invest some time and maybe make. It's been discussed as part of integration with I know perf dash or has been already discussed or we would like to in etcd solve the problem of we have some soft metric that we want soft validation metric and we would like to measure it and observe its trends so we can not necessarily same like coverage. You not necessarily want to block a PR because it's lower your coverage, but you want to measure the trends and see the trends and change to be able to course correct. Because if there is a negative trend and we don't see it, we at some point will find ourselves so deep into it that will be much harder to wait. It will be much harder to find a way back. So that's my two approaches. If you're interested more, so that would be from more test integration, and if someone is interested in test infrastructure or work, that would be any of those areas should be good to look into.
Yeah, I can take a look on this.
Okay, awesome. So let me write down the ideas. So improve. For business. Yeah. So this is those are areas that would be great. I think, and both issues would be good to work towards. Yeah. If sorry, it's hard to follow the chats. Are there any questions in chat?
So I just wanted to ask, I was going to post, but I guess I'll just ask. So the
Sure.
SIG Pro test, is there a repository where we can just go to check for this?
For protests?
Yes.
Sure. It's so Pro itself is a project, but also is test infrastructure. If you go to Kubernetes test infra, maybe I can. Oh, this is an old one. So all our configuration for testing lives here. Oh, this is test grid config. Sorry, this is test grid configuration. So test infra is a repository that includes all configuration of infrastructure that is run by Kubernetes. It includes configuration for test grid and configuration for Pro, which is here. I don't know where it is. Okay, let's go back. And test grid jobs. It's not Pro, it's jobs. Maybe we have a separate, possibly we have separate. So here is all the links for all the jobs that we have. And there are separate efforts to migrate etcd from Git flow or GitHub workflows to Prow, because it's, you know, it's more advanced, more community supported infrastructure with more visibility graphs and everything. Like those kind of graphs you can are hard to get, and many other perks. So yeah, let me post a link quickly. Yeah. Any other questions? Let me show, just post the links. Yeah, I can. I mean, I can pause. Before I mentioned that. If you want to CC or assign yourself, let me. You can just go it. I don't. I'm not always creating direct issues on the GitHub if not needed, because there is a tendency on GitHub for people to take the issue and not necessarily and block it, and not necessarily not all issues move forward. And some of those robustness test things might be a problem that needs to be solved earlier than later. And it's a little bit harder for anyone from community to pick it up. Okay, going to the main part of the meeting, let's look at the recent things on the robustness test. Just check. So yeah, with the last two improvements, we've seen a lot, much better results. So we have a pretty much full green situation for main branch. And hopefully it stays that, but it just means we can start possibly considering like adding more features, so we can like to go back into the cycle of we can introduce some new things or cover new part of API, and so it will we will get a clear signal if we find any issue. It will be clearly showed up on the dashboard instead of being covered by layers and layers of flakes and everything. So yeah, that's good to see. Same situation on ARM. We have very good now ARM infrastructure, much better than previously. We had a lot of issues with ARM being slower, but now looks great. 3.5, we have 2 failures. On ARM, we are pretty clean. On 3.4, we have still 2 failures. I think those are still member replace. But I was surprised to find today that on ARM we have maybe 3 new failures. So let's try to look at them. Where is it? Okay. So looking at the it's okay. So we have a failure. This is just to keep track. We have ARM, AMD on 3.5. And the failure, and looking at the failure, we have a delay pure network, and we have still minimal QPS. So even though we reduce the QPS requirement from 200 to 100 QPS, we still have a flakes. We still sometimes go below 95, 100, and more often than we would want. We have one failure also in the this 3.5 on AMD, and this is before or after we lowered QPS. I think this is before we lowered QPS, so it's so this run here is from August 22nd, and we lowered QPS on November. Oh, we keep the. No, this is coming. November 20. So yeah, this is. I expect the last QPS thing, or at least one of the last flags before we change the or QPS or flags due to QPS on level 150. The next one, this is a member replace, and it's it happened. This is an echo, or we expect this to be fixed. So let me mark it as so. Let's just confirm this. To the web test. It's December 1st. Should fix. Be fixed, and this should be fixed with next failure. And here we have we can see that QPS. So this is November 23rd. And QPS was. Okay. Yeah. Yeah. So like QPS remains the main source of issues that we still see, and that's why we've been lowering the requirements and trying to as much we have of people working, and we don't like it's not the most important thing just to fix the infrastructure for robustness test. We want to fix on the correctness and be able to have a stable infrastructure to build things on it. Let me just clarify and speed it up. So yeah, looks like from last 2 weeks we don't have any new type of failure. Most can be classified and should be fixed with the two bugs. The only exceptions are cases where we get QPS much lower. Based on the analysis, I think we can if we looked at the analysis, it should show us that there should be a coverage of QP. There should be a visible correlation between which cases it happens. I think this is the main scenario that this happens, and this scenario easily gets 1% gets below 1% percentile. I think for lazy FS we disable the QPS requirement, or we put it very low. I don't even remember. But yeah, I think we should consider lowering the requirement for the that's maybe interesting. One node cluster struggles with throughput, request throughput, which also can be, it can give us information, because one node cluster versus 3 node clusters, and 3 node clusters you should have 3 times more writes. So which means that maybe the issue is not disk based, which is interesting. Yeah, so it could show that even like improving changing the VM could possibly not improve here much. Why I think it's, or if we look at the code, or we have been running the robustness tests. If that still first, if there is one node, it can serve less requests, but still all writes are getting through one member. So this would mean that we have less read capacity. So possibly there is a lot of, and maybe second thing that may surprise me is this is also a problem with Kubernetes traffic. Looks like, yeah, also Kubernetes traffic is heavier than etcd high traffic, which that could be a hint. Yeah, because here we have etcd getting 150 over 150, while Kubernetes is getting low. So if we see correlate, so this is surprising for me for one reason, that Kubernetes, the heavy operations are mostly in etcd. So for example, in Kubernetes we don't test large objects. So I think the size of the object is like capped to like bytes, while on etcd side we have something like testing large put, which on large put we write like at least 32 kilobytes, which is not the biggest data we could store, like far from it, but still much bigger than any other put. So I was more expecting here issues here. yeah. So yeah, having this data would really or having already this data is already we can make a lot of decisions. I think high level would be good to investigate why this is a problem. Mm. Okay. So yeah, if last thing, if you look at all of those tests, this is Kubernetes, this is Kubernetes, this is Kubernetes, this is one case where it's etcd based, and etcd and etcd. So we have half split. So one idea that comes to my mind is assumption for the assumption for the QPS. We split QPS two QPS profiles. This profile, where to I click. Okay, so this is in traffic. There are two profiles that we run: low traffic and high traffic. Just difference is how much data we can, like, what is the maximum QPS that we want to put. Original reason for limiting the maximum QPS was there are a couple of very costly operations for linearization that we wanted to avoid to having too much QPS. But at this point, I think one of the factors that could be contributing to the issue, or no, this is high traffic profile. Yeah. Or I would think that one thing that could be contributing to low traffic getting out of QPS is just not enough window for that traffic to really for enough requests to have time to execute, but due to maximal QPS. Yeah. Like I said, I think we need more data with the dashboard and have ability to analyze it more. I would consider a couple of tweaks in the QPS. So, but yeah, those should be. Yeah, I think those are hard to make reason of because they cannot be tested until we roll it out to robustness tests and see how they behave on CI. One of the surprising issues we have is in cases where we hit very low QPS, the main issue is not that we cannot do this number of QPS. The problem is that we get a lot of failures. So if you look at the logs, we hit for some reason we only are able to do 60 QPS and this, but this counts only successes. So if we counted maybe failures, that would give us around 100 QPS, like if or at 90, I think. So yeah, for some reasons, some requests that should be taking milliseconds here reads are taking multiple seconds, hundreds of milliseconds. So we are reading code just 10 keys. And yeah, okay. I don't see, and here compaction is very, very quick. And I don't think I want to bore you with debugging etcd performance. The only thing it's surprising is I don't see any trace logs. So usually if you would want to debug such information, this only informs you that there was a request that took more than normal to execute, which just it's a warning that there is a request that takes over 100 milliseconds. But the useful part is traces, but I think they only kick in much later in the request execution. I think they take over in the apply loop. So for some reasons, this etc didn't want was rejecting requests. They didn't even go through Raft, I think, which is weird. Okay, yeah, that's high level, like the top issues that we are like currently working on. If you want to help with one of those issues, please let me know. If not, I think we can I know open again to discuss to questions, and if not, we can yeah, that would be it. Are there any questions? Okay. Yeah. If not, let me give you back 10 minutes. I think we can finish early. Yeah. Okay. Okay.
Thank you.
Thanks, Tim. See ya.